Hello and welcome to our third tutorial in Vasari. So, the last two tutorials we've taken how to make a mass and how to manipulate this mass. So, the next step is how to make an actual site where you have other buildings in it, and how to start to analyze the wind analysis and the solar analysis for your building or for your project. So, the first step in our tutorial is to locate our project location. So it's very important to pick the right location since it will differ in either the wind analysis or the solar radiation analysis or even the energy analysis. Okay. But this tutorial we're gonna only talk about the wind and the solar analysis, and in another tutorial, it's the fourth part, we're gonna talk about energy analysis. So first of all, we select the location from Analyze button. We can select the location from this button here, or we can select it from here. And you can notice that the default of the program is Boston. So we're gonna change this set location into our university in the ABC. So first thing, we're gonna make this project address to ABC, Egypt. And as you can see, we selected our location here. This is the ABC campus. And as you can see here, there are different pins and having something like a weather station. This weather station differs from one area to another. So in the fifth settlement, تجمع خامس, the weather stations are different than in Middle Cairo. For example, this weather station here. And so we have to make sure that we're selecting a weather station that is near our campus. And we can see the list of weather stations that are near to our campus here. And as you can find, all the 4 weather stations are 9.01 kilometers away, so it's okay to select any of those weather stations. Okay, the next step, after we selected our location, we can start importing this a site image where we can have the neighboring buildings and the neighboring topography of our site. So we go to the import site image from here, this button, and we wait until it loads. And it's very important to know that you must have an internet connection when you're working on Vasari, because most of the analysis, whether it's energy or solar analysis, it's made online on online servers, and so is acquiring the image or acquiring the location. You have to get it from Google Maps or from Bing Maps usually. So this is our university, okay, and let's select a site for our analysis or for our building. So we can, for example, take a site maybe somewhere. Let's take it somewhere here. Okay, so we have some buildings around, and we're gonna make our site in this place. I'm not sure if the site you're gonna use it has some specifications or not, but let's make a hypothetical site right now. And after that, we import the image. I'm gonna import it from here. And as you can see, the image is imported into our world, the 3D world that we have here. So after we've imported this image, now we can trace the buildings. I don't know if the colors are not very good here. Okay. Oh, okay. So we're gonna trace the buildings surrounding and for any as we assume that our site is here. So let's see how this will affect our analysis. So I'll start by building creating mass, and we've already known how to create masses, and so I'll skip this part or make it faster. As you can see, mm, while I'm making the mass, I'm not taking accurate measurements, and so it's just like a very rough representation to our surroundings. So I don't have to make the whole model of the building. I can take some parts of it that are related to my site. I don't have to make the whole buildings. So the next step here is to create the solid form, and I have to make sure that the solid form is accurate. It must have the same height of the buildings. So if this is a SSE building, so we know that we have 3 floors, and it's around 13 or 14 meters if I remember correctly. So we're gonna make this 14 meters, for example, like this. And this is this is a footprint to the part that is related to our site for the SSE building. And we're gonna have our site in this place, for example. Okay, so after we finish the first mass, which is this SSE building, we're gonna finish this and start making our site location or determining the site location, which you've already done before, so far. So I'm gonna make another hypothetical site shape, and since it's so far I don't have any model conceptual model made yet, so we're gonna make the site as a cube or as a cuboid here, something like this. Okay. It depends, of course, on the dimensions of your site. So let's take it something like this, and we can extrude this solid form. Make it, for example, maybe we can make this 9 meters. And then we'll finish the second mass. So now we have two masses. Mass number 1, which is SSE building, and our site location. Okay. So the next step, after we determine our location and our masses, we're gonna start analyzing those masses. And notice in the analyze tab, there is a part which is called energy model display. This part is very important when we're selecting other types of model display, which we'll come to talk about it later in the energy analysis part. So far we're using the show mass form, which is just the masses, the outer lines of our masses, which is very beneficial in both wind analysis and solar radiation. So we're gonna start first with the wind analysis, and As you can see here in the wind analysis or the climate analysis, we have both something called wind tunnel and the windrows. Of course, you know the windrows from other courses. Um, it shows us the probability of the wind throughout the year or throughout a certain period of time, and and it shows this um, this windrow shows us the location the the wind direction according to the location we selected. So if we selected the university, which is in the fifth settlement, so we're gonna see uh, windrows with those um, directions. If we changed our location, let's say for example we've changed it to another place, it will take another form. So let's change it, put it for example in a further part of Cairo, or maybe we go to Alexandria, for example, it will be different, of course. Okay, it's not updating yet. Okay, so maybe it's not updating, or I have to change the location from. Okay, so the location is not changed. I have to change it manually from settings and location, and so the windows will be different. Okay, so now okay, this is the windrows on our site. So this is on the map, and this is on our site, and as you can see, this site. This is the north, east, and west, and south. So the wind comes from north or north, nordic, east, and the different colors here represent different speeds of wind. So we're talking that throughout most of the year, uh, the wind direction is from north and northeast, with an average speed between 3 and 5, or 5 and 6. So we're talking about an average speed from 3 to 6. Okay, so this is the windrows, and it's important to know that if you're gonna put windrows in your project or in your presentation, you have to understand well how it's spread, and why did you put it here? Why did you use the windrows in your analysis or in your presentation? And another thing to notice here, there's two timelines down here. One for the months, December, June, January, where you can change the slider to specify the wind direction or the wind probability in a certain period of time, as well as with the second slider here, which is about hours. And the same goes here, we can change the slider to know the wind probability in certain hours of the year. But it depends on your how you're gonna analyze your site. You don't have to make it very detailed. You can take like a general overview, so we can take it an annual wind analysis. Okay, so this is the windrows. And the windrows is gonna be used in the wind tunnel. That's the next step, which is the wind tunnel. We're gonna use this windrows, or we're gonna use the analysis that we made from the windrows that the probability of the wind is from north and northeast. We're gonna use this in the wind tunnel. So now I've pressed on the wind tunnel. It will take a while to open. Okay, and this is another window with the wind tunnel engine. It's a part of the Vasari, but it's like a plugin inside Vasari. So now we have our mass, the conceptual masses that we've made, and we have like some moving, as you can see here, moving the wind representation. This is a representation of the wind. So now we know, and this is the windrows that we've talking about. We've talked about this windrows here, and you can see that the direction of the wind is preset to go from north to south, which is our most common or most dominant wind direction throughout the year. Uh, and if you want to change the direction or you want to change the speed, we can do this from this part here, which has real-time analysis. Okay, we can do a 2D analysis or a 3D analysis, and we can change the velocity of the wind. And as we said before, that probably the average wind speed in Cairo is between 3 and 6. From what we've seen or what we've observed from the wind rows. So we're gonna make this, for example, to 5.5, okay? And the angle is 180, which is north. Okay, so now we've started making our direction, our wind direction, and we have to notice, okay, that how to read this. We have to learn how to read this graph. So, for example, we're having a wind from the north, okay, from the north to south. So the wind is coming to this direction, and according to our buildings, most of the wind is blocked away from our side. So basically, our side doesn't have any. The wind speed of our side is not very high, and we can see the difference in colors, which is represented in this legend. As you can see here, the maximum wind speed is 10 and the minimum is 0. Okay, if we change the wind direction, start to change the wind direction from here, okay, maybe we can make it something that's not in our windrows, but to see the effect. If we make it from west to east with a slight inclination, you can see that the wind is entering through this part, and it has it becomes or it goes or flows inside between the buildings with a higher speed. So this is a part that is concerns the dynamics and the fluid mechanics of the buildings or of the surfaces that we have. So by changing the direction of the wind and the wind speed, we can start getting different results and start simulating how the wind will move if it came from this direction. You can start by taking screenshots for your buildings and your site, and start analyzing and trying to explain how the wind affects how the wind is on your site. Okay, so this is for the 2D analysis. You can change, of course, this is a 2D analysis, so you can change the position of the grid that has the wind on. So we can take it from a lower level, which won't differ a lot in our case here, since it's a bunch of cubes and so. Okay, or we can take the slice not only on the XY axis, or we can take it on the YZ, for example, here to start to measure our wind, or we can take it on the XZ direction, as you can see. So this is the wind in this plane. Okay. And if you want to start displaying the wind analysis in a more 3D way, we can use this 3D analysis. So we've changed our analysis from 2D to 3D, However, we're still showing the 2D slices. You can close this and start a 3D volumetric analysis. So for example, there are types of 3D analysis. For example, the point cloud display, which displays certain points, as you can see here, and each point is represented by a color, which represents a value of wind speed in this part. You can see this from here, our legend here. Okay. Another very interesting kind of 3D analysis is the flow lines analysis. First of all, we have to set up this type of analysis. So for example, if we're having wind from let's make this again to 180 degrees. So we could have wind from this direction, which is north to south. So we have to choose the setup of the flow line settings. So we can use the flow line settings, and as you can see, there's like boundaries to flow from, which are the direction of the wind or the position, the plane that the lines are created, or the flowing lines are projected from. So we're gonna make our projection plane is the Y plane, not the Z plane. It's a YZ plane, not okay. So once we press apply, you can notice now that the wind starts flowing from the YZ plane. Of course, you can start changing number of lines, segments per lines, and other things, as you can see here. We can decrease the number of lines to have a smooth or a smoother presentation of the wind flow. So we can see how the wind moves, and the color is represented. So yellow means it has high speed, and when it goes through the buildings, it starts to have a lower speed. And that's how we can do wind analysis, and what types of wind analysis we can do. Okay. After having our wind analysis, now we can move to the solar analysis, which is in the form of solar radiation analysis. So the solar radiation analysis is performed on the massing surfaces, the different surfaces that we have here. We can start performing our solar analysis on. So we go to analyze solar radiation. We have to make sure that we have an internet connection to have this radiation. So the first thing to do in this analysis is selecting the faces to analyze. Select mass faces to analyze. So for example, I don't want to analyze solar radiation on the other building's SSE building. I want to only analyze it on my site. Okay, so I start to select the faces that I want. So for example, this one, and this one. Okay, and the other two sides from the other part of the site. And it starts to get tricky when you start selecting the other faces. So now we have our faces, our 5 faces here. Okay, and we can finish this from pressing again on this button. Now we have our faces selected. So yeah, it started automatically making the analysis, but let's ignore this now. The second thing is sun settings from the sun study, where we can change at what time we make our analysis. So for example, here the sun study is made in the springtime. So, and we can enter here 2 more options through these 3 dots here to know more about analysis made. So the solar study that we are making here is with the sun study is a still image or a still time which is a point in time for this analysis. In just at 1 second, what is solar radiation on each surface. But for more complicated or more sophisticated analysis and more um, detailed analysis, we can use the single day analysis, which makes an analysis throughout the whole day. So for example here it shows that the date is 1/6/2012, the time is between 10 to 4. So it will take all so it will take the whole solar radiation on the day and starts giving us results based on this. And we can change the time interval to smaller time intervals if we want, but 1 hour will be fine. And we can change here the presets. So for example, we want to make it at the summer solstice solar study, which is the highest sun of the year. And winter, this one is the winter one is for the lowest sun of the year, where it's the shortest day and the lowest sun. And spring and autumn, or spring or fall, are nearly the same. So we can make both summer and winter analysis, for example. Just to know the extremes. The summer is the hottest day and winter is the coolest day, so we can know the extremes of our analysis. So it takes the summer first. The next part here is the analysis accuracy. So as we go higher in the resolution, we have a more accurate analysis. And it's more preferred to have a higher resolution, of course, but I'll leave it now for 50 until I start changing the other items here, so it won't take time each time I change an item. So for the data display, we have first thing is the type of data display. We can make it cumulative or average or peak. Cumulative is having summing up all the hours that we've calculated, all the radiation from all the hours that we've calculated. The average, we take the average of those hours, and the peak is the maximum solar radiation throughout the day. You can use any of the three, but I prefer if you use the cumulative or the average. The peak, yeah, it's fine, but if you want to know since we're making it a day study, not only 1 hour from the sun settings here, it's still day study. So it's preferable to use either average or cumulative analysis. And make sure when you make the winter, you're gonna make the summer and the winter analysis, you choose the same settings for fair comparison. Okay, so we change the units from here. There are 3 units: watt hour per meter square, and kilowatt hour per meter square. The difference between watt and kilowatt is you multiply by 1000, and the BTU per feet square, which is SI units. We're not going to use this, of course. For the analysis, we use either the kilowatt hour or the watt hour. That depends on whether you've made your analysis cumulative or average. Having a bigger number, so you have to change this number into kilowatts, for example. But for now, let's make it watt per hour. And then in the end, the style, where you can change the style of the analysis that you have in the end. You can have the Equisac style, which is the old style that you use in Epitact, and you find a great resemblance in the style. Okay. Or you can use the solar radiation default style, and you can change the styles from here, having changing the settings of the styles, the colors, and so and the legend. Okay. You can make for an accurate analysis, you can make maximum or minimum. You can see here the values of the maximum or minimum. You cannot change those values. So, for example, if you make it summer solar analysis, the maximum will be different than the maximum of the winter analysis. So to unify the numbers in the legends or the previewing to analysis, we can change those numbers in maximum and minimum and add other numbers to unify our legend, but we'll come to that later. So now we can start to analyze. Okay, so first of all we make the resolution higher and we start analyzing our surfaces. As you can see, it didn't change so much since our building is very uniform and it's very it's only a cuboid shape. And you can notice here the numbers. This is a cumulative analysis. We have numbers starting from 4,200 watt-hour to 76, which is the lowest solar radiation. We can change those numbers from watt-hour to kilowatt-hour, so the legend changes into smaller numbers. And this is the maximum numbers that we have. So on the roof here we have nearly 4.2 kilowatt-hour of radiation. And on the other sides, you can see that the colors are nearly the same. So to avoid this, you can remove the roof from the analysis since it's making the number very high. So we can remove the roof from the analysis and start to see the difference between the colors here. It's starting to get more sensible. You can see that you have very high solar radiation in the west since it's open space, but in the east, for example, here you don't have that much higher solar radiation since you have a building here that covers your site. So this is basically the wind and the solar analysis, and you can change. Now we can change the level since you have the maximum here is 1.3. If you made a winter analysis now, you will find a difference in the numbers. You can see here, making a wind analysis. Okay, so we have the maximum number in the legend here is 1.4. So we can change this number, change the number of our legend here. We make this number 1.4. To do this, we can add another color from here, another color here, and make it also yellow. So we have the maximum, which is the yellow color, and make it 1.4. Okay, this is the maximum. And press OK. Of course, it won't change in the winter, but if we get back to the solar analysis, summer solar analysis, we'll have our maximum, in the legend it's written 1.3, but in the colors here it's gonna be 1.4. So this is a solar radiation analysis. You can start taking photo, images and capture image photos and analysis, and start discussing where you should put your shading devices, for example. So in this case, since the West is having the most solar radiation, so we have to make sure that we covering or protecting our west facade, also as well as the south facade here. For the west, for the east, for example, we don't need any protection from the sun, and of course from the north, we're trying to maximize the solar radiation that we have here, since it doesn't have any direct sunlight. So basically, those are the two main analyses that are made here. the solar radiation analysis and the wind analysis or climate analysis. For next time, we're gonna introduce the energy analysis, which is more complicated and sophisticated than the other types of analysis that we have here. So see you next time, and I hope you start applying this on your models soon.